Hi, I'm Miss Hearn. Let's get started. In this video, we're going to discuss how to identify prime and composite numbers. So we need to define what that means. Well, a natural number greater than 1 that has only itself and 1 as factors is called a prime number. A natural number greater than 1 that is not prime is called composite. One way to think of prime numbers is to think of them as any number that has exactly two different natural number factors, 1 and itself. And by the way, 1 is not a prime. Historically, it was at one time included in the primes, and mathematicians found that to be very inconvenient because more often than not, when they wanted to use primes and properties of primes, they would have to specify all the primes except 1. So they just stopped including that in the primes. So if we want to determine if a number is prime, like the number 2, we check what its factors are. And the only numbers that go into 2 are 1 and 2. The number 3 is the same way, so it's also prime, 1 and 3. It has exactly 2 factors. Unlike the number 4, which has the factors 1 and 2 and 4 are all numbers that go evenly into the number 4. So this does not have exactly two factors. So these two values, 2 and 3, are prime, whereas 4 is composite. Now, one systematic method for identifying primes is known as the sieve of Eratosthenes. To construct a sieve or sieve, list all the natural numbers from 2 through some given natural number, as high as you want to go. And we know that the number 2 is prime, but that means that all multiples of it are composite. So we circle the number 2 and cross out all the other multiples of 2. And we continue this process with crossing off all multiples of primes, and we see what's left. All right, so we're going to start here. I've gone from 1 to, that's supposed to be 120, not 1,120. 1 to 120. And we know 1 is never considered a prime anymore. And so we circle the 2, but if 2 is prime, because it only has 2 factors, then any multiple of 2 is not. Like 2 times 2 is 4. So 4 has the factors 1, 2, and 4. So this is not going to be a prime number. But that's the same for all even numbers. So you can actually very easily scratch out entire columns, in this case, of numbers, and we've eliminated them as possible prime numbers. Okay, next we move on to the number 3. 3 is a prime. It's only divisible by 1 and 3, so I'm going to circle it. But then I'm going to basically skip count. Every third number is a multiple of 3, and I'm going to cross all of them off. It may be that some of them are already crossed off, like the number 6 was also a multiple of 2, so it's already crossed off. But in any case, I'm going to go through and I'm going to cross off every third number. So 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, and so on. Okay, so I've crossed off all the multiples of 3, and now we're going to move on to the next number that we need to check, which is the 5. We know 5 is prime, but then that means that every multiple of 5 is not. So, and the 5s are nice because they're lined up. The multiples of 5 are multiples of 5 or 10. So we can cross off both of these columns. Okay, and now we're going to move on to 7. There are no other multiples of 5. So 7 is a prime. And now we're going to go skip count to every 7th number, every multiple of 7. So we're going to go 7, 14, 21, 28, 35, and so on. All right, and the last one that we cross off is 119. That's a multiple of 7. And now see how everything else up to 11 is crossed off at this point. So 11 is the next number that we check, and it is a prime. Okay, so 11 is prime. So now we're going to cross off every multiple of 11, like 11, 22, 33, 44, 55, 66, 77, 88, 99, and 110. All right, now we move on to 13. 13 is prime, only 1 and 13 go evenly into 13. And now we cross off every multiple of 13, like 26, 39, and so on. All right, the next prime on our list is going to be 17. And we're going to cross off any multiples of 17. The first multiple of 17 is 17 plus 17 is 34. The next one on the list would be 51, and so on. All right, that leaves the next prime on our list being 19. And now we cross off any multiples of 19. 19 times 2 is 38. 19 times 3 would be 57, and so on. The next prime on our list then is the number 23. And we would go to the multiples of 23. So 2 times 23 is 46. 3 times 23 is going to be 69. 4 times 23 is going to be 92, and so on. The next prime on our list then that has not been crossed off is 29. And the first multiple of 29 is 58. The next multiple of 29, 60 plus 27 would be 87, and so on. At a certain point, the multiples get so large that they go off the list, and so you know that you can just circle all the remaining numbers and they all must be primes. So you have all the primes less than 120 circled on this page. It turns out that there are an infinite number of primes, though. That can be proven mathematically. So how do we decide, given a number that's not on our list, whether the number is prime or composite? Well, one way to do it is to actually go back to the list and see if the number 89 is a prime, and it is. Another way to do it is to start looking for factors of the number by just dividing methodically starting with the smallest prime, which is 2, and then the next prime, and then the next. How about 83,572? So how could we determine if that number is a prime? So we would start with dividing by the factor, the prime number 2, and notice that this is an even number. You may be familiar with the fact that any number that ends in an even digit is itself called an even number and is divisible by 2. So then that would tell you that it's composite. If anything other than the number 1 in itself goes in, then it's a composite number. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video.